In this video, we're learning how to use tree diagrams to calculate probability. So imagine I pose the question of what's the probability of getting a heads 3 times in a row flipping coins. We can't use a two-way table to calculate this because there's 3 events that happen. So we have to use a tree diagram. Well, first off, we'll establish what we know. There's heads and tails, there's only 2 different options. So 1 out of 2 options, that gives us a probability of a half or a 0.5. So our tree diagram looks like this. We have an event, which we can say is here, and then that event splits into 2 different scenarios. We can get a heads or we can get a tails. That's our first split, our first event. The probability of getting a heads is 0.5 and the probability of getting tails is 0.5. Then, once we have that first coin flipped, we again can flip another coin. And when we flip that coin, we get either a heads or a tails. And when we flip the coin the second time, we still have a probability of 0.5 of getting heads and a probability of 0.5 of getting tails. Then, if we were to flip the coin a third time, we could get heads or tails again, and we can get heads or tails again. So we have heads or tails and heads or tails. And again, we need to fill in the 0.5, 0.5, 0.5 and 0.5. Now, just for the sake of showing the full diagram, I'm going to do the same out here as well. So we have 0.5, 0.5, and we have heads or tails. And here again, we have heads or tails and heads or tails. And each time we flip a coin, doesn't matter how many times you do it in a row, the probability of getting heads or the probability of getting tails will be 0.5. So now we want to get heads 3 times in a row. So we have heads here, we have heads here, and we have heads here. The probability of getting the first heads was 0.5. The probability of getting the second one was 0.5. And the probability of getting a third heads is 0.5. If we want to find the probability of those mutually exclusive events, independent events rather, we need to multiply the 0.5s by each other. So 0.5 by 0.5 gives me 0.25, and multiply that by 0.5 again, that gives me 0.125. Again, you can use your calculator for that, so no panic about it. So that's 0.125, or we could say that's 12.5%. And we could also say that is an eighth. So if we look at the total amount of outcomes that come out of this, well, here's one outcome, heads, heads, heads. Our next outcome we could look at would be heads, heads, tails. Then our next one we could look at would be heads, tails, heads. Our next outcome would be heads, tails, tails. And that's 4 outcomes so far. Our next one is tails, followed by heads, heads. Then we get tails, heads, tails. Then we can get tails, tails, heads. And finally, we have tails, tails, tails. So that's 8 different options. So that's where we can get the 1/8. In our next scenario, we're looking at the probability that Peter scores a penalty. So the probability he scores a penalty is 0.8. We want to find the probability he will miss his first penalty and score the second. So first off, the probability he scores is 0.8, which is also 4/5 or 80%. The probability that he misses will be 1 minus 0.8, so that'll be 0.2, which again you can say is 1/5 or you can say is 20%. For tree diagrams, it's going to be a little bit handier if we leave them as decimals or fractions, or, well, actually, no, it doesn't really make a difference. So, first off again, we split the event. He can score or he can miss. The probability that he scores is 0.8 and the probability that he misses is 0.2. He takes a second penalty. He can score or he can miss. And again, if he misses, he takes the second penalty. He can score or he can miss. And we're saying that this is a mutually exclusive event because his confidence isn't affected regardless whether he scores or misses. He's not more or less likely to score depending on what he did in the last one. So again, if we want to find out the probability that he scores his first 2 pens, we have to take the 0.8, multiply it by 0.8. Because again, we're looking along this line. So it's probability he scores and then scores again. So this is the line we're looking at here. So that's probability he scores and scores again. So 0.8 multiplied by 0.8. And that goes about 0.64, I think. Yep, so that's 0.64. Then we'll have the probability he scores and then misses. So the probability he scores then misses will be 0.8 multiplied by 0.2. So 0.8 by 0.2 will be about 0.2. Sorry, so that's 0.16. Would have worked differently. Anyway. Then we have the probability that he will miss and then score. So miss and then score, just again, so we look along the line. So we have that he misses and then he scores. So that's 0.2 by 0.8. So 0.2 by 0.8, I'm sure we'll notice, will give us the same answer. So we have 0.2 multiplied by 0.8, so that'll be 0.16. And then we have the probability that he misses and then misses again. So that's 0.2 multiplied by 0.2. And the 0.2 by the 0.2 gives 0.04. So the probability that he misses his first and scores his second is this one here. So he misses and then scores, so that's 0.16. Now we just want to make sure of something. We want to add together these probabilities and make sure that they add together to give us 1. So we have 64 plus 16 plus 16 plus 4. So 16 and 4 will bring us to 20. Add a 16 will bring us to 36. 36 and 64 brings us to 100. So that's 1.00. Your 4 probabilities here need to